This is question 9 on the exam 1 review for math 3. Given a point on the unit circle that corresponds to a real number t, find the exact value of the 6 trigonometric functions of t. Okay, so we haven't really worked with t so much in the class. It was included in the notes, but usually we've worked with theta. So when you're actually solving this, it's not really going to be any different than using the variable theta. But just to be clear about what the difference is between theta and t, when we're talking about a point, let's say for example negative root 2 over 2 comma root 2 over 2 on a unit circle, there's an angle associated with it, which of course is theta. Now, in addition to that angle, there's also a arc that's associated with it, or an arc length, essentially. Instead of thinking about how far you're traveling in terms of an angle, think about if you're on the surface of this circle. How far are you traveling in order to get to that point? And that value is t. Now, again, that's the theory basically behind it, but when we solve, it's really not going to make a difference whether we use theta or t. So if you want to take out t and just put in theta, it's not really going to make that much. It's not going to make any difference really. Okay, now the key phrase right here is this is a point on the unit circle. And so when we find the values of the 6 trigonometric functions, that is when we find the values for sine of t, cosine of t, tangent of t, cosecant of t, secant of t, and cotangent of t, we are going to use the unit circle definitions. So in general, sine of t would be y over r. But because we're on a unit circle, and a unit circle has a radius of 1, we can just simplify this to sine of t equals the y coordinate of that point, of that coordinate pair. And so in this case, our coordinate pair is negative root 2 over 2, comma root 2 over 2. The y is root 2 over 2, and that's it. Cosine will of course be the x coordinate. In general, it's x over r, but on a unit circle, it's just x. And that's negative root 2 over 2. And then tangent of t, the definition of tangent of t is y over x, which again, when you think about it, you could just do it as y, which is root 2 over 2, times the reciprocal of whatever is in your denominator, in this case x. Reciprocal means switch top and bottom in the fraction. And when you do that, you actually end up, these end up reducing to 1. So don't forget that there is the negative sign right there. It's easy to forget that. Tangent of t equals negative 1. Okay, now we've done sine, cosine, tangent. We would want to find cosecant, secant, and cotangent as well. Easiest way to do this a lot of the time is just to, for example, cosine of t. Remember that it's the reciprocal of sine, or the reciprocal of it's 1 over y. What you can do is you can just flip your value for sine of t, and just get rid of any radicals that might be under the might be in the denominator. So when we do this, we flip it. That is something you're gonna have to memorize, the relationship between sine of t and cosecant of t. We have to multiply both top and bottom by root 2 over 2 by root 2. And that gets us 2 root 2 over 2, which of course simplifies just to the square root of 2. Right, there's a similar relationship for cosine of t and secant of t. I'm going to cheat a little bit here. I already know what's going to happen when I flip root 2 over 2. It's going to be the same thing as what happened when I solved for cosecant. The only difference here is that I need to take care of that negative. So Officially, it would be negative 2 over the square root of 2, and you would multiply top and bottom by square root of 2. But I already know how that's going to come out because I already saw what happened when I solved for cosecant of t. And so this is just going to be negative square root of t. I don't necessarily have to show work for that because the work that I did for cosecant of t essentially was the same. Okay, last but not least, cotangent of t. You can use the unit circle definition, or really the definition, which is x over y, or you can use the identity, which I recommend. Remember that tangent and cotangent are reciprocals of each other. So this is 1 over negative 1. And in that case, that just simplifies down to negative 1. Okay, so now that we have the idea there, we found the values of each of these trig functions. Now that we have the idea, let's move on to an example that's a little bit more algebraically more difficult. Let's put it that way. And that's part B, which is the same idea. We're going to look for this point, or we have this point on the unit circle, and we want to find the values of sine, cosine, cosecant, secant, tangent, and cotangent. Sine and cosine are of course very easy. They're both equal to y and x respectively. So that's really easy. And then cosecant and secant, we can take care of those. Just find the reciprocal. And if necessary, then clear out any radicals from your denominators. And that's really it. So I guess I lied when I said that this was algebraically more difficult. It looks actually pretty easy now that we think about it. Okay, last but not least, tangent of t. That's y over x. And in this case, your y is root 21 over 5. And again, instead of dividing by my x of 2/5, I can multiply by its reciprocal. And you see actually this one ends up being actually very easy. Those reduce to 1, and you're left with root 21 over 2. Okay, now cotangent, of course, I can use the fact that it's the reciprocal of tangent of t. And what that means is I can just get this value and flip it. And of course, I'm going to have to do the same thing with the radical I always do. I multiply by my fancy version of 1, which is just radical 21 over radical 21. And you get 2 root 21 over 21. All right, and that's it for this example. Thank you.